Hey everybody. Today, what I want to go through is a review of our rational numbers. You had some experience going through and reducing fractions and changing our fraction form from a mixed number to an improper fraction and backwards. What I want to do is I want to kind of dive in a little bit and start working with our rational numbers. What you see on our screen is our definition again. In red, there is our formal definition. You can see that what I've circled in gold, that fractions can be written in the form m over n, where m and n are integers. So our rational numbers have to be in that form. No. What I want to do is I want to kind of go back now, and I really just want to zero in on that word can. Rational numbers are numbers that can be written in that form as a fraction, but they could also be written in other forms. And so where I want to kind of jump in then is, well, what happens if we take that m over n form and we manipulate it? We do some other things to it. And so what I've circled in gold with our m over n, you'll see in a star at the bottom of the page, what if we actually do the division operation? So my fraction line means divide. What if I actually take m and I divide it by n? Well, sometimes that can work out to be a whole number. Sometimes that works out to be a decimal. Sometimes that works out to be an ugly decimal. We should know that when I do the division, if it is a rational number, then my decimal is repeating, or it terminates, or it ends at some point. So what we want to do today then is we just want to jump in and we want to start playing around with number forms. We're going to be working with fractions, or its decimal parts, or our percent form. So for today, we're going to be jumping around. You are going to want to have your calculator with you today. Okay, let's jump in. So what you see on the screen right now, there's 4 problems. We want to work our way through. You'll see the instruction says to convert to decimal form or percent form. So we're going to jump in on what I would call pretty straightforward with question A, and then we're going to work into some uglier stuff towards question C and question D. So let's jump in on A. We have 3/4. So the problem says to convert. And maybe we're good that another word for convert is change. So I have to change that into a decimal. Well, for us to change a fraction into a decimal, that means I need to do the division operation. So I'm going to take 3 and I'm going to divide it by 4. Now, for a lot of us, when we see 3/4, like the way I even read that, when I read it as 3/4, I think we should be okay to say that that is 0.75. Because 3/4 has 75 cents. I will expect that for you to change a fraction into a decimal, you'll have your calculator with you. So we are simply calculating 3 divided by 4. However, big picture, I would hope that we know 3/4 is 0.75. And worst case is we practice to be able to know that. Okay, and now I need to change that into percent form. And maybe we remember that all percentages are out of 100. And so for me to change a decimal into a percent form, I have one of 2 ways. A default for a lot of us in the past would have been to take that 0.75 and multiply it by 100. Since all percentages are out of 100, then I want to multiply that by 100. And I get 75%. However, I have to be honest with you, if I'm finding a percent, I don't multiply that one by 100. I use my place value. And so for some of us with our place value, we may remember that 0.75, that last digit, the 5, is actually in the hundredths column. And so if I wanted to think of that, I could think of that as 75 hundredths. And since all percentages are out of 100, I can see my out of 100 right here. And so I can see that my top value is 75. Just a different way to think about it. For most of us, I think we're dealing with the pink. So to change a fraction to a decimal, we have to do the division. To change into a percent form, maybe we're thinking about out of 100. Okay, what I'd like you to do now is I'd like you to take a moment and try to work out ahead of me. So I'm going to put a little line right down here to separate question B. And what I would like you to do is to try to change the next 3 values into a decimal and a percent form. And then we'll come back and we'll see how well we did. Okay? I want you to pause the video now. Okay, we're back. So we're going to work our way through having to go and change 7/3 into a decimal. Well, we could pull out our good old calculator. And when we do that, we are going to get 7 divided by 3. Well, 3 goes into 7 2 times, and then we had this 0.333, and depending on how many decimal places your calculator shows, that 3 could go on for a while. Now, I'm hoping we remember that that 3 is then repeated. It goes on forever. So then it just becomes, well, how do we write it? Well, first off, we do not copy out the number of 3s that our calculator screen shows and say, hey, there's my exact value. No, I got it. You don't. You're only showing what your calculator shows. So we can't do that. If we feel like rounding that, we can't do that either, because now that's not exact. 7/3 does not equal 2.33. So how do we show our repeated? Sometimes I'll see students who will put a bar above the 3. And I want to stop you from that, because that's actually not the correct usage of your repeated symbol, although I know a lot of you have been taught that in the past. You have 2 repeated symbols. You have a dot and you have a line or a bar. This would be an instance where we should actually say 2.3 and put a dot on top, because it's just the digit of 3 that repeats. Let's say we had a different number. Like, let's just say I'm pulling a number out of nowhere and I say, I don't know, like 4.7575757, and the 7.5 repeats. So now there's multiple digits that are repeating. That's when we use our bar. So since the 75 both repeats, then we put a bar or a line over the pattern of decimal places that we see repeat. So there's your difference between when we use the dot and when we use the bar. Okay, hopefully that clarifies. You're good. Regardless, we're now back at our decimal form of 7/3. I'd like to maybe tackle that a different way, because I think you can deal with B without a calculator. And what it does is it requires us to change that fraction into a different form. We should be okay that we could change 7/3 into a mixed number. And so you would say to yourself, okay, how many times does 3 go into 7? Twice. because that's 2 times 3 is 6. You have 1 left over, and we're talking about thirds. If you can change your improper fraction into a mixed number, well, then you can see, there's my 2. And if we get enough practice with it, we can remember that 1/3 is 0.3 repeated. I think it is worth your while to try to memorize that 1/3 is 0.3 repeated. And so if I was to tackle that problem, I'm not pushing buttons on my calculator. I'm changing my original fraction into an improper fraction, into a mixed number, and then knowing what I know about fractions as decimals. Something to keep in mind. Okay, I'm going to get rid of that little pink and gold that I just put in. And then I'm just going to include my 2 1/3 as a reminder. Okay, I've done the first half of part B. Now I need to change it into percent mode. Well, if we know all percentages are out of 100, then we can go ahead and we can multiply that by 100. So 2.3 repeated times 100. That is going to get me 233.3333 on for, and we should know that those 3's repeat. So for us, for rounding rules, unless the problem doesn't state otherwise, you can round your percentages to 2 decimal places. Just make sure that you're marking it as a rounded figure. I like the purple. You telling me 233.33%. However, you could give me the exact value of 233.3 repeated percent. Just as good. Okay, with those 2 questions done, I think some of you might be able to remember back to maybe a little trick you saw in the past about how we can change a value when we multiply by 100. Can I get you to look back to where I just put the yellow star in the solution to A? My 0.75 times 100. Some of us will remember a little trick that when we multiply by 100, we could move the decimal place 2 spots. 2 spots to the right. Because when we multiply by 100, we're making the value bigger. And maybe that's how you got your 75. On 2.3 repeated, we could move the decimal place 2 spots to the right. We just have to remember that with 3 repeated, there are 3's going everywhere at the end. Okay, hopefully that works out. Okay, I want to talk to you guys about C and D, not because I think that they should be a problem. Given what we just talked about on B, you have a chance to make any corrections to C or D. So I want you to pause the video, make any corrections you want to make, and then we'll come back and we'll check. Okay, pause it now. Okay, we're back. So I think you should be okay on C and D. I want to show you a little trick that I've come up with over time that helps for me when I am dealing with 11ths and 9ths. This trick only works for those fractions. Don't try it elsewhere. The question that I ask myself is, what would I add to the bottom to get me up to 20? That's my goal. So I want you to focus in on question C, 5/11ths. What would you add to 11 to get up to 20? Hopefully we're good that that's a 9. So what you do then is you multiply the top by 9. Now, you might look at that and go why would you? Okay, fine, I'll go with it. 5 times 9 is 45. Well, maybe you can kind of see where 45 popped up in your answer. If I was to take 5 and divide it by 11, I'm going to get 0.45454544, and maybe we can see that we get 0.45 repeated. So I know how to properly write that now. I put a bar across both the 4 and the 5. That's the way I remember how to change 5/11ths into a decimal. What would I add to the bottom to get to 20? Multiply the top by that. Now, that might seem random to you, and I have to be honest with you, it is pretty random. But the reason why I use that trick is because it also applies for 9ths. What would you add to 9 to get to a 20? You'd add on 11. So multiply the top by 11. And you would get 0.44 to 44 to 44 or 44. So really what you have is 0.4 repeated. There you go. There is a little trick where you can deal with 11ths and 9ths without a calculator. So just to make sure we're good, I'm going to throw one more up. What if I gave you 7/11ths? Take a moment right now, just off on the side, try to change 7/11ths into a decimal. Okay, pause it now. Okay, we're back. So hopefully we looked at it and we said, okay, what would I add to 11 to get up to 20? I would add 9, so I multiply my top by 9. Okay, 7 times 9 is 63, so I have 0.63, and remember it's repeated. So if you got that, great job. Great job. If you want to get really good at it, then just try to practice that as much as you can. Okay, I'm going to erase all that stuff I just wrote down because we need to finish off the second part of that problem. Change each of them into percentages. The best answer for all of those would be multiply it by 100. So that would be a 45.454545. So I could say 45 repeated percent. Just be very careful here that if you wanted to give me a rounded value, then we know we round off to 2 decimal places. You get 4. That 4 is too small to bump up that 5. And so when we round that thing off, we will get the same, but approximately 45.45%. Okay, I'm going to sneak a little line in here so we can keep that other portion divided. Once you found that 4/9 was equal to 0.4 repeated, then we're pretty good to be able to go through and say multiply that by 100 and tell me that it's 44.4 repeated percent, or it's approximately 44.44%. And hopefully we match up. Okay, we spent a lot of time talking on that. But you having the ability to change a fraction into a decimal will become an important part for us. Not when we're dealing with some knowledge or some theoretical stuff, but when we get into application problems and how we use fractions, we're going to be changing a lot of things into decimals. Okay, let's change gears a little bit. I have 2 more fractions for you, but you'll notice that both of them are improper fractions. I want you to take a moment, pause the video, change each of those into decimals and then percent form. And we'll use these as our gauge. If you're feeling brave, try to do it without a calculator. See what you can come up with. Okay, pause the video now. Okay, we're back. So I should be able to move pretty quickly. I would be doing this without a calculator by thinking, how many times does 5 go into 12? 2. How many are left over? 2. That's a 2 2/5. Because I know that every 1/5 is equal to 0.2. So if I wanted to change that into a decimal, I know I have the whole number of 2, and then my bits, I have 2/5. So I have 2.2s, which is 8.4. So that's how I tackle that with no calculator. Of course, you could have just punched into your calculator 12 divided by 5. Okay, we're going to change that into a percentage now. We are either multiplying that by 100, we are thinking about place value, or we're using that little move the decimal place. Either way, we should have come up with 240%. If it was move the decimal place, keep in mind you have an open spot to fill in terms of your place value. Fill it with our 0. Okay, I'm going to confirm on F. Same process, no calculator. I'm looking at how many times does 3 go into 17. That is 5 times. 3 times 5 is 15, so I have 2 left over to get up to 17. So I at the very least know that my decimal form is 5 point something. With no calculator, I know that 1/3 is 0.3 repeated, so 2/3 is 0.6 repeated. There we go. And for final confirmation, change that into a percent. 566.6 repeated percent for perfect, or 566.67%. Remember, that 6 is going to bump up our 7 as an approximate. Okay, so hopefully those went well and you feel pretty comfortable making those conversions. Okay, job is to get lots of practice with that stuff. Make it so that it's fluent. Okay, what you now see on your screen is we're going to go through and we're going to convert, but we're going to change our number forms. So you'll notice that what I've given you on your screen right now is decimal form. We're going to go and change it into a fraction, which means I need to put my fraction line back in there. I need to put my division line back in there. And percent. You're going to find that I'm going to tackle this in the opposite order, because since I already have it in decimal form, changing that into a percent is pretty quick. So what I would like everybody to do, take down those 4 questions, copy them down, and I want you to change them all into percent form, all of them right away. Okay, pause the video. Okay, we're back. So very quickly, I can multiply all those. Well, hopefully we remember that 0.5 is 50%. I don't think we've memorized 0.4, but if I think about that as a 0.4 times 100, then I get my 40%. And again, maybe we're looking at moving a decimal place through multiplication. C is actually pretty straightforward. That gives me my 36%. And D, we should have got down to 12.5%. So hopefully we match up on the percentages, and I would use that as a gauge. If we struggle through some of that, then that means we've got some stuff that we want to clean up. I just don't like that dash through my 0. Okay, where I want to spend our time now is working through on the fraction component. Because for most students, it almost feels like going backwards. Taking a decimal and going backwards to build the fraction is one of the more difficult actions to take. So let's spend some time doing it. I want to walk through question A, and I want to tackle it a couple different ways. First off, I would hope that I would have a majority of you that would know what fraction 0.5 represented. Like you'd especially know what fraction it presented when you see that it's worth 50%. But I want everybody to imagine we have no clue that it's a half. No clue. How can you build that fraction? Okay, one of the ways we can do it is through place value. You look at that 5, the last decimal place, and that is in our tenths column. So you can write it as a fraction. The first thing we know, fractions do not have decimals. So get rid of the decimal. That gives us 5. What was the place value that the 5 was in? It was in tenths. So make it out of 10. But what we created was a fraction that is not fully reduced. And so we need to simplify it. We can simplify it by seeing we can divide top and bottom both by 5. And that gives us our 1/2. Nice. There is one way to view it. The other way you can talk about it is to kind of remove your place value and you count decimal places. Now, there is a little bit of a danger, a risk of mistake here. So you have to be very focused that what we are counting are decimal places. Not whole numbers, but decimal places. And so what we can do is we could view that and say, well, decimals have no fractions. Fractions have no decimals. So I get rid of my decimal and I have 5. I had one decimal place, and notice in my original, one decimal place. So I write it over my 1 with 1 0. One decimal place means 1 0. And you come in on the same 5/10, and then you can spend some time reducing that to 1/2. Okay, I'm going to show you both of those things in action, and then I'll show you where it can cause you a little bit of a jam sometimes. Okay, if you're feeling confident to try B, C, or D, give them a go. Pause the video, you give them a shot on your own, and then come back and we'll see if we match. Otherwise, I'm going to kind of slowly work our way through those 3. You pause it at any time you feel comfortable to try a problem on your own. Okay, let's jump in on B. I see that I have 0.4. Well, I know fractions don't have decimals, so get rid of the decimal. That's a 4. My 4 is in the tenths column, so I write it over 10. And then I can reduce. Or you viewed it as fractions don't have decimals, so I have a 4. I have one decimal place, so I need it over 1 0. And there's your 2 ways to come in on 4/10. We go ahead and we reduce that. You can divide top and bottom both by 2. There is your 2/5. So, how well did we do? Okay, as I said, I'm going through all the problems. You pause it at any point where you think you're comfortable to try on your own. Okay, I'm going to jump into C. I have 0.36. Fractions don't have decimals. So, I have 36. 36 what? Well, that last decimal place is in the hundredths column, so I write it over 100. Or, as you work your way through, I have 2 decimal places, so I need to write 36 over 2 zeros. Either way, we come in on 36 over 100, and now we need to reduce. In this case, you could divide top and bottom both by 4. 36 divided by 4 is 9, and 100 divided by 4, I know that, easy. That's quarters. 25 cents. There's my 25. Okay, last one. You take a look at 0.125. Well, either way we're coming in, we should have 125 over something. Either the 5 is in the thousandths column, so we get 1,000, or 3 decimal places means 3 zeros. Now you reduce. Well, this might be one that takes a little more. Like, I would hope that at the very least we see that our numbers end in 5 and 0, so we know that 5 will divide evenly. But maybe even more so, we see that my number ends with 25. 2 zeros is 100. 25 goes into both of those numbers evenly. You start reducing those fractions, and maybe we divide top and bottom by 5. And then we go, hey, another 5 goes in. So we divide top and bottom by 5. And then we go, hey, another 5 goes in. So the best number to divide by at the very beginning was actually the top. And if you followed that advice, we would have divided by 125. And we get down to 1/8. Okay, hopefully those went okay. And maybe we're feeling a little more confident changing a decimal back into a fraction. Okay, here's our last set of problems. I warned you a little bit at the beginning that the way we can deal with this, there can be a snag, a risk for mistake. And I'm going to walk through E and F so we can see where. First off, we can change those into percent form. You can do that. Give it a shot. What I also want you to do is I want you to take question E only, and I want you to change question E back into a fraction as well. I want you to do both parts. And then I want you to come back and we'll check and see whether we hit that snag or not. Okay, so I want you to do both E and F, change them into percent, but just question E, convert that into a fraction. Okay, pause it now, give it a shot. Okay, we're back. So I'm hoping that maybe we multiply by 100. So we move the decimal place 2 spots. Maybe that's a case where we come in on 160%. And maybe visually you can see it without drawing the arrows. We have 384%. Okay. Now we're getting confirmation on changing E into a fraction. So the first thing we say, fractions don't have decimals. So get rid of the decimal. That gives me 16. Either method, 16 on top. Now we got to figure out what the bottom is. So we look at our place value, and our place value puts 6 in the tenths column. So I write it over 10. And some of you just found your snag. You didn't write 10 on the bottom. Because we mistakenly were using that zeros trick, that pattern, but we didn't pay really close attention to my wording. How many decimal places do we have? You'll notice we only have 1 decimal place. Don't mistake that for how many digits do we have? We have 2 digits. I'm not looking for digits. I'm looking for decimal places. So how many decimal places? 1. So we write it over 1, 0. That's going to be your mistake. I would have expected potentially for a 16 over 100. However, you have the means to check that. Look at my fractions, and I can reduce those right now by dividing top and bottom both by 2. Those get me to 8/5. And I should have a means to do the fastest check as to whether that's reasonable and whether I made that mistake. Look at your fraction form and look at your decimal form. Remember that improper fractions, where the top number is bigger than the bottom, all give me values bigger than 0. Sorry, bigger than 1. So I have 1 and a bit at least. And so I get that confirmed in my yellow fraction. Look, my top is bigger than my bottom. I go back up and follow my arrow. I get a decimal value bigger than 1. I'm good. Watch what happens if we make our mistake. And the common mistake was in the blue. We would have put an extra 0 down there with the digits mistake. Well, you reduce top and bottom, and maybe you get to your 4/25. Or at the very least, you stop here. Hey, look, I have a proper fraction where my top is smaller than the bottom. That means I should have 0 point something. Oh, shoot. I got 1 point. I know I goofed. And you can go back and you can find your mistake and you're good. So keep that in mind as we go. That is a very useful check for you to have. Okay, now what I want you to do, pause the video super fast and finish off F. Go to it. Okay, we're back. So for us to work our way through, either way, I know I can get rid of my decimal or have to get rid of my decimal because fractions don't have decimals. And now I take a look at the 4, it's in the hundredths column, or I have 2 decimal places, 2 zeros. Hopefully we match up. And the hardest part of this problem was trying to reduce. Now, if you have a calculator at your disposal, don't bail out on dividing top and bottom by 2. Don't. If you see 2 goes in, and you look at 100, and you know that, like, well, 4 goes into 100 because that's my quarters, then do a quick check and see, does that divide by 4? Try to reduce as fast as you can. And maybe we notice, hey, wait a second, 4 goes into both the top and the bottom. So if I divide my top by 4, then if I took 38 and I divided it by 4, I get 9 with 2 left over. 24 divided by 4 is 6. On the bottom divided by 4 is 25. And there is no hesitation about whether that is fully reduced or not. Because you guys take a look at the bottom of that fraction and you notice 25 is only made up of 5s. So the only number I'm checking to see, does it go into the top number, is a 5, and I can clearly see that 5 does not go into 96 evenly. So I know that I'm correct, fully reduced. Okay, there we go. There was a review on how to change numbers from fractions into decimals into percents, or decimals into percents and into fractions. We need to be good at being able to manipulate the form that our rational numbers take. Your job now, jump in and get as much practice as you can, because we're going to be using that skill, that ability, throughout the rest of our semester and, frankly, throughout the rest of your mathematical lives. So jump in, get as much practice as you can to make it automatic. Okay, good luck, guys.